Okay, I know some of you guys are having difficulty with this idea of proof, and specifically with writing these simple algebraic proofs. So I wanted to give you an example that you could follow step by step. So what we're going to start with is the claim, and this is the conjecture that is in need of proof. And my claim is that 3 times some number plus 7 is even when n, the sum number, is odd. And you can mentally plug in 1. 3 times 1 plus 7 is 10. That's even. Mentally plug in 3. 3 times 3 is 9 plus 7 is 16. Plug in 5. 3 times 5 is 15 plus 7 is 22. So in 3 cases of a little bit of mental math, when n is odd, 3n plus 7 is even. That's my conjecture, but that's a conjecture that needs proof if it's going to become a theorem. The needed facts for this type of proof are that 2 times any number, m, is always going to be even, and 2 times any number plus 1, or minus 1, but I've used plus 1 here, is always going to be odd. Here's the proof. Since I believe 3n plus 7 will be even when n is odd, I'm going to let 2m plus 1, the form of my odd number, equal n. Now by substitution, I'm going to rewrite 3n plus 1 as 3 times 2m plus 1 plus 7. So I'm plugging the form of an odd number in for n. And now just do the math. Here's a distribution. 6m plus 3 plus 7. Combine like terms. 6m plus 10. We're expecting 6m plus 10 to represent an even number. So I'm going to factor out a 2. 2 times 3m plus 5. Now, 3 times any integer plus 5 is going to give me some other integer. So I'm going to state that 3m plus 5 equals k. And then I will rewrite 2 times k instead of 2 times 3m plus 5. 2k has the form of an even number, so my proof is complete. Now in the second column, I'll define each one of my steps. 2m plus 1 equals n. This is a definition of a variable. Here, by replacing n with 2m plus 1, I've used substitution. And here, by multiplying the 3 by the 2m and the plus 1, I've done distribution. Three plus 7 equals 10. That's combining like terms, or just addition. Here I've factored out the 2. So this is a factoring step. Here again, I'm defining a variable. I'm saying this thing right here, I'm going to call that k. And to get to my last line, I'm going to use substitution. Since 2k has the form of an even number, 3n plus 7 is even when n is odd. But the truth is, proofs should read more like poetry than they do like procedures. Here's the same proof, but presented in a more elegant manner. Let 2m plus 1 equal n for all m's and n's that are elements of the integers. See that 3n plus 7 equals 3 times 2m plus 1 plus 7, which equals 6m plus 3 plus 7, which equals 6m plus 10, which equals 2 times 3m plus 5. Since 3m plus 5 is an integer, let 3m plus 5 equal k. And observe 2 times 3m plus 5 has the form of the even number.